What is thermal runaway for emergency responders? Have you ever wondered what happens when an electric vehicle battery goes haywire? Let's talk about a serious issue called thermal runaway. This phenomenon occurs in the lithium-ion batteries that power electric vehicles. It is a self-accelerating chemical reaction that can lead to a rapid and uncontrollable rise in temperature. When thermal runaway starts, it usually begins with an internal short circuit or damage to a battery cell. This damage causes the cell to heat up excessively. As the temperature rises, chemical reactions inside the cell produce even more heat. This creates a feedback loop that can escalate quickly. The internal structure of the battery breaks down, leading to further short circuits and heat generation. One of the most alarming aspects of thermal runaway is that it can spread from one battery cell to others, potentially involving the entire battery pack. Several factors can trigger this dangerous situation. Manufacturing defects, physical damage from a crash, overcharging, or exposure to high external temperatures can all be culprits. Even mechanical shocks during rescue operations can worsen the situation. For emergency responders, understanding thermal runaway is essential. The fire generated by thermal runaway is challenging to extinguish. The chemical reactions inside the battery continue to produce heat, even after applying water or other extinguishing agents. This can lead to the fire reigniting after it seems to be under control. Additionally, the battery releases highly flammable organic electrolytes and toxic gases, which pose serious respiratory hazards and explosion risks. The sealed steel battery enclosure makes it difficult to dissipate heat and access the fire for firefighting. Responders may need to use large amounts of water or even flood the compartment after opening it, which comes with its own risks. Another concern is that thermal runaway can occur unpredictably. It may happen minutes or even hours after the initial impact or damage. This makes ongoing monitoring crucial during emergency situations. Emergency responders must approach electric vehicle fires with caution. Using appropriate protective equipment and specialized training is vital to manage the risks associated with thermal runaway. Stabilizing the vehicle and carefully assessing battery damage is essential to avoid triggering or worsening the situation during rescue operations. In summary, thermal runaway in electric vehicles is a hazardous chemical event that leads to uncontrollable heat and fire. It presents unique challenges for emergency responders, especially regarding fire suppression and safety during rescue efforts. Understanding these risks is key to effective emergency response involving electric vehicles.